Step 5.2 Distance-based methods. We are looking at partitioning methods now, and we want to apply those now after we have applied them to an artificial data set to real data, and indicate how much more difficult things might be if the cluster structure isn't as obvious as in an artificial data set. What we're doing is we're using again the tourist risk-taking dataset we also used in hierarchical clustering that contains 563 respondents and 6 variables where people indicated how often they did take certain risks. So we already loaded the data in the part on the hierarchical clustering, and now we want to run the k-means algorithm on it for different number of clusters because we don't know a priori what's the correct number of clusters, and we run k-means algorithm rapidly with several random initializations as starting points in order to increase the chance of finding a good solution. Because this uses random initialization, we need to fix the random number generator in order to get reproducible results. Then we're calling step cclust with our data set. We're looking for solutions between 2 and 8 clusters, and for each number of clusters we repeat the k-means algorithm with 10 random initializations. This returns an object of class stepFlexClust, and if we plot that object we will get the scree plot. So the scree plot should help us to decide on a suitable number of clusters. It has the number of clusters on the x-axis, the sum of within cluster distances on the y-axis. Sum of within cluster distances is sort of the criterion we're optimizing in k-means, so this is a decreasing function, and what we'll be looking at is sort of an elbow. So we can see there is quite a strong decline between cluster from 1 to 2 cluster, but there's still something happening later on, and from the picture 2 clusters might be indicated, but we could also think that another number of clusters might be suitable. Like there's not much happening after 6 clusters anymore. And we can now look at different cluster solutions for different number of clusters using that object returned, because this contains all the models for 2 clusters, 3 clusters, and so on and so forth. And we can, for example, access the 2 cluster solution using the subsetting. So the 2 square brackets, it's the same subsetting as we would use for lists. And then we say, which solution do we want to have? We say we want to have the 2 component solution, and the bar chart will give us the profiles. In a sense, it plots the centroids of our clusters together with the overall averages. So what the bar chart does, if we construct it, we zoom in, is we get a conditioned plot. We are conditioning on cluster membership, so we get 2 panels for our 2 clusters. Here in the strip we see how big our clusters are, so they're about both containing one about 40, the other about 60% of our observations, so that's rather evenly split. And obviously here, if we look at the average risk taking for each of the variables within the cluster, it's always way higher than the average risk taking of the total population, which is represented by the red dot. And the reverse holds true for cluster 2, where in general this contains respondents which are less likely to take any of the risks than a random person selected. So the 2 cluster solution differentiates between risk-prone and risk-averse persons. If we want to look at a more distinct clustering, we can also look at the 6 cluster solution. You might want to recall that we also looked at the 6 cluster solution for hierarchical clustering. This is now using a different criterion to group respondents into 6 clusters, but we can also look at that solution. And we might also want to compare this solution to the 6 cluster solution of hierarchical clustering. And if we would do so, we would see that The partitions obtained slightly differ, but the tendency of what we can detect, for example, having two clusters containing respondents which are rather risk averse, and having one cluster which is prone to take health risks but not so much any of the other risks. These are features which we can see in both of the cluster solutions, either obtained with hierarchical clustering or with k-means clustering.